Hi everyone. Today we're going to cover section 10.3, which is dealing with composite figures. So all these composite figures are figures that are made up of simple shapes. So for example, the triangles, rectangles, trapezoids, all those things that we've been working to find the area of so far. So it's going to be where we take a couple of those different shapes and put them together to make a single shape. So when we're finding the area of a composite figure, all we're going to do is find the areas of the simple shapes, and we're either going to add or subtract them depending on what the figure is. So probably the trickiest part of this in some cases is going to be to figure out what are the simple shapes that make up that composite figure. So for today, again, our target is to find the area of a composite figure. So our directions say to find the shaded area, and that's going to be important, especially a little bit later. And now we're rounding to the nearest tenth if necessary, but again, we don't want to round until the very last step. So we'll see what that looks like. Some of these it's not going to matter as much as others. So if I look at number 1, there's a lot of ways that I could break up this figure. I'm always looking for the fewest number of figures that I can divide it into to make it the easiest problem. So for example, I might see that I have a trapezoid, a triangle, and then 2 triangles down here. But if possible, I want to actually avoid dividing it into 4 shapes. I want to make this as easy as possible. So when I look at this, and especially given the information that I have, I notice that here in purple, I have a parallelogram. And this is going to be a nice shape to work with because I notice I have the base and the height of that parallelogram. So while we're here, let's go ahead and do that. We know the area of a parallelogram is going to be base times height. Well, the base of that is going to be 8, and my height, this perpendicular distance, is 5. So I know the area of my parallelogram is going to be 40. Now, if I look down here, I actually am going to run into trouble if I try to use 2 triangles because I don't know the bases of each. But what I can do very easily is find the the area of this whole triangle here. So in orange, I'm going to do the area, and I'm just going to use a little triangle. So the area of my triangle, again, my formula is 1/2 base times height. So I'm going to take 1/2. The base of my triangle here is 10. The height is that perpendicular distance, which is 5. And so that's going to give me an area of 25. So now if I want to find that total area of the composite figure, I'm just going to add those 2 areas together. So 40 plus 25, or 65. And again, I'm going to be careful to include my units. So I have 65 square feet. So that one's a nice, easy one. Okay, and number 2. Hopefully, right away should jump out at you. This composite figure is made up of 2 simple shapes. I have a semicircle on top. And then down below, I have a trapezoid. And these are going to be nice and easy because we're given all the information that we need. So I'm going to start with the area of my semicircle. Now, the only thing I have to be careful of, since this is a semicircle, we're going to take our area formula, which is pi r squared. We're going to divide that by 2. Now, the other thing we have to watch out for is our area here, our radius. They're giving us the whole diameter, which is 20. So my radius, I know, is going to be half of that. So my radius is 10. I still have to divide by 2. So 10 squared is 100. Divided by 2 is going to give us 50 pi. Now, ultimately, later we'll be rounding that, but I don't want to do that until that last step. That's what this note was about here. So now we have to find the area, I'm just going to say, of our trapezoid. I know that's h over 2 times b1 plus b2. And now we can just substitute because we're actually given all that information. The height here is 14 over 2, and then my bases are 20 plus 32. So we can get our calculator to calculate that area. I'm going to simplify a little bit here. I know 14 divided by 2 is going to give me 7, and then 20 plus 32 is 52. So I get an area of 364. Okay, so now I've got the individual areas, and again, we're going to add them together. So my total area is going to be 50 pi plus 364. And now here's where we can put this into the calculator and then round at this step. So to the nearest tenth, we're going to have 521.1. And again, with our answer, we're going to include our unit, so 521.1 square millimeters. Okay. Now let's look at the next one. So the first thing I'm going to try to do is decide the shapes that I need to break this up into. So there's a couple ways I could go here. I could take this triangle on top, plus this rectangle, and then add the semicircle. But to me, again, my goal is to get this in as few of shapes as possible. So I actually noticed that I can take this whole trapezoid here and then add my semicircle on the bottom. So then I only have 2 shapes to worry about. So let's deal with our trapezoid first. We know the area of the trapezoid is h over 2 times b1 plus b2. Now, if I try to find the height, I'm actually going to quickly realize here that I don't know the height of my trapezoid. So here's where we have to do a little bit of work. We're going to end up using this triangle here to find that height. And here's how we're going to do it. If we call this h, and actually let me pull this triangle down here. I know this is h, and I know that this is 10.2. Now, 7.8 is the base of that whole trapezoid. But if this piece is 3, I know this other leg of my right triangle must be 4.8. So now I'm going to use the Pythagorean theorem here to solve for h. So h squared plus 4.8 squared is going to give me 10.2 squared. And now we can use our calculators to solve for that height. So I'm going to do 10.2 squared minus 4.8 squared. And I get h squared is 81, which is nice because I know the square root of 81 is just 9. So it's a nice, easy number to work with. So now that I know that height, I can go ahead and find the area of the trapezoid. That height that we just found, the height of that triangle, is the same as the height of my trapezoid. So we're going to have 9 over 2 times b1, which I'm going to call 3, and b2, which is 7.8. And if we put that into our calculator, so 9 over 2 times 3 plus 7.8, it's going to give us 48.6. Now, one thing I want to say here, it would be fine if you actually decided to do the triangle plus this rectangle. That would give you the exact same answer. So now we're going to do the area of our semicircle. Again, that semicircle is pi r squared divided by 2. So I have pi. Now, this height here of our triangle or trapezoid is the same as the diameter of our semicircle. So if my diameter is 9, I know my radius has to be 9 divided by 2, or 4.5. So my radius is 4.5. I'm going to square that and divide by 2. So simplifying a bit, let's see, we're going to take our fraction, pi times 4.5 squared. Whoops, I just deleted it. And we're going to divide that by 2. Let's see, let me do this. 4.5, we'll just deal with this. 4.5 squared, divide by 2, it's going to give me 10.125 pi. So for right now, I'm going to leave the pi in. So now that I've got my areas, again, we're just going to add them together. All the examples on this page are examples of adding our areas. So the total area is 48.6 plus 10.125 pi. Let's move this over. And I get an area that's approximately 80.4 square feet. Okay, I think that's enough examples for right now of adding areas. Again, if we need to, we can always go back to number 4. Essentially what we have here is a square, and then really we're going to be adding a circle because those two semicircles are going to add up to a whole circle whose diameter is 3. So if you want to see that one tomorrow, we can go over it in class. But for now, we're going to look at some, instead of where we're adding all the areas, we're going to look at some where we have to subtract some area. So let's go to the next page and look at 5 and 6. Now, our direction said to find the area, or the shaded area. In this case, there's not shaded, but we want to look at the area that's kind of bound by these solid lines here. So what I'm sketching in here is really what we're looking for. So this orange shaded area here. So what I'm looking at, or what I'm thinking when I'm looking at this, is really what I have is a rectangle with two semicircles subtracted from it. Now, since those semicircles are going to have that same diameter, really what I have is a rectangle minus a circle. So I'm just going to make note of that here. We have a rectangle minus a circle, because those two semicircles are going to add up to a whole circle. So let's take first the area of our whole rectangle, which I'm going to outline in blue. I'll let the camera readjust here. Okay, so my area of a rectangle, I know, is just base times height. The base, they tell us, is 33, and the height is 16. So that's a simple calculation for us to do. And we get an area of 528. Now, we're going to subtract out these semicircles. And again, since I have two semicircles that have the same diameter, what I'm really subtracting is a circle. So I'm going to find the area of that whole circle. Now again, this 16 gives us the diameter of that circle. So we want to take half of that, or 8 for the radius, and we're going to square it, and we get 64 pi. So now we have to be careful that we're not rushing through. To find our total area, remember now we want to subtract. So I'm doing 528 minus 64 pi, and we get approximately 326.9 square feet. All right, one more example for today. Again, this is going to be subtracting. And so when I'm looking at subtracting, I'm trying to think of what my outside shape would be. And so if I look at this, I'm actually going to take the outside of all of this here, because a rectangle is about the easiest thing we can work with. So I'm going to take the area of my rectangle. So I'm going to kind of write the area of the blue rectangle. Now, I notice then I have to subtract this little rectangle. So I'm going to write kind of some unofficial notation here, minus the area of this little rectangle. And then I'm going to take out this orange trapezoid up here. So I'm going to subtract out the trapezoid. Okay. So now we just have to figure out all these dimensions because it's not really explicitly given to us. So for the area of my big rectangle, I need the base times the height. Well, the height we know that's 12. Now, the base here, I know this piece is 16. Now, if this is a rectangle, I know this is congruent to this, so this is going to be 6 as well. So now the whole base of our rectangle is going to be 22. So I have 22 times 12. If I multiply those, I'm going to get 264. So now I'm going to look at my little triangle, or excuse me, not triangle, my rectangle. Again, I have base times height. Now here, I do know the base of that rectangle. We already said that was 6. But now I have to look at the height. Well, here I know the height of my big rectangle is 12. This piece here is 7, which means this here must be 5. So the height of that rectangle is 5, and I get 30 for that area. So the last piece now is the area of that trapezoid. Again, formula is h over 2 times b1 plus b2. The height they give us explicitly is 4. So I have 4 over 2. One base is 7. But now we have to figure out base 2. So let's take a look here. I know that this side of my big rectangle is 22. So if this piece is 4, 22 minus 4 is going to give me 18 for that remaining piece. So now I know that base 2 is going to be 18. So if I add that up, I have 25. That's times 2, and that gives me an area of 50. So now to find that total area, take my big rectangle, and I'm going to subtract off the little rectangle and my trapezoid. So if I subtract this, I'm going to get an area of 184, and that's square meters. So you'll be getting a couple days of practice on these just to make sure we're kind of clear on how do we pick the shapes out, and then also do we know when to add areas and when to subtract. So that's it for the video right now, and we'll see you tomorrow for practice.